So this is the review for the Chapter 8 quiz. Today is November 23rd, 2025. So would anybody like to start us off with any questions? I have infinity up. I can bop around into other areas too if you want me to. Does anybody have any questions?
I don't have like a specific affinity question, but when you do the ratio test and you end
Yeah.
up with one, which means it's inconclusive,
Right.
what's kind of like the next step forward? Like the lectures didn't really go over it too much, but the affinity things were kind of like, oh well, it's inconclusive, but it's also this, so ta-da! And I was like, wait, what? Uh,
Just depends on the function. Ratio test is best when you're dealing with um, a combination of polynomial, factorial, and exponentials. Usually you'll get, if you have exponentials or factorials, use the ratio test. If you don't have them, you might want to look at another test like the comparison test or what other ones are there? So it's hard to say what the next one would be. There's no hierarchy. Um, but generally speaking, the ratio test is best when you have uh, a general nth term that contains a combination of factorial and exponential. And frankly, it can have polynomial, but the polynomial part won't really change it much. So all the critical value, all the useful values will come out from the factorial and the exponential parts. Did you have one in mind that you wanted looked at?
Not particularly. I think it was just the like going into from the lecture videos, they kind of only go over the ratio test, and then going into the Infinity ones, kind of like having to backtrack and read the textbook or something else to try and figure out what some of these are doing.
Well, um, yeah, I mean, I don't know. I can pull up like a random section here. Let's look at 8.6. I just have, I'll share it here. No, maybe not that one. Give me a moment. So maybe let's try 8.4. All right, so I'm gonna show you 8.4 here. I'll share my screen. So you've got this nutty looking thing right here. I'm gonna copy it down. It's 8n squared plus 1, 7 to the n plus 4, 5 to the n. We're trying to figure out if this darn thing converges or not. So I'll stop the share, go to my overhead. Oops, let me pin that. Give me a second here, get things arranged. So what you want to do, here's what I do. It's going to be a lim as n goes to infinity. It's kind of a mess. What I usually do, well, I don't really need the absolute values. There's nothing negative here. I copy it once. Sorry for my sloppiness. Where I have n plus 1 inserted. Now n plus 1 here will just make n plus 5. Now I have to divide that whole thing by this expression with just n. So I'm going to go ahead and just cheat. I'm going to go right to the next step, which is I'll flip it over. Okay. You see what I did there? So I'm basically, this is a to the n plus 1. This is divided by a to the n. I'm just flipping it over and multiplying. And I can clean this up. You'll notice that I have an extra 5 factor down on the bottom than here. So all these guys cancel with all but one of the 5s. I have an extra n factor, so I have n plus 5 and n plus 4. There's one more up here, so all of these guys will take out all of these guys. Now here's the thing with polynomial. Um, if you do the leading coefficient test, you're gonna have quadratic up here and quadratic up here. You're gonna have 8/8, which is just 1, so that doesn't change anything. So you get, did that again. So you get 7/5 for your ratio test. That's greater than 1, so the series converges. I'm sorry, diverges. So it's diverges. If the ratio test gives you greater than 1, it's divergent. If it's less than 1, it gives you convergent. And if it's 1, you are you have no conclusion. That help? I'm looking at some of these. These look like absolute nightmares, but they're actually not that bad. I think the intention of some of these questions is just to kind of make them look. They look intimidating, but they clean up real nice. I'm looking at 8. Again, I'm in 8.4. I just pulled this one up. I'm going to share the screen again. So take a look at this one right here, number 2. It's the square root of n plus 4, and then n plus 1 factorial, and then e to the n plus 9. And again, it looks pretty rough, but I'll just copy it. But because it's got factorials and power or exponentials, this one is ideal for ratio test. In fact, you know what I want to do? I want to scroll. This one is interesting. I'm going to copy this one down too. Let's take a look at both of these. It's 15 to the n plus 1, and then the 11 to the 2n plus 1. Let's see what else is kind of interesting. Number 4, I'll copy that one too. Uh, I'll tell you what, I'll come back to it. Again, as bad as these things look, they're not too bad. So when I do the a to the n plus 1, I just add 1 to all the n's. I get n plus 5. This becomes n plus 2 factorial. This becomes e to the n plus 10. I'm going to divide by, so I'm going to flip it over the original, just like that. And it reduces pretty nice. All the factors down here will cancel out all the factors up here except for the n plus 2. The n plus 2 will survive. You have n plus 9 factors of e up top. You have one more on the bottom. So all these guys take out all but the e. And these are, well, they're not polynomial, but they're going to give you a radical of n plus 5 over n plus 4, which is going to be radical 1. So this part will just go to 1. So you have lim as n goes to infinity of n plus 2 on the top over e on the bottom. And that's going to go to infinity. So that's going to diverge. Okay. And by the way, factorials always outgrow exponentials. And this thing is having absolutely no effect. All right, so there's a hierarchy in terms of what outgrows what. Factorials outgrow exponentials, exponentials outgrow polynomial. Right here, this looks a little funky, so, but be careful. If I do the n plus 1, I get 15 to the n plus 1. I'm going to have n plus 2. I can tell you right now, that's not going to really affect anything. When I do n plus 1 here, I have 2n plus 2 plus 1. So it's 11 to the 2n plus 3. And now I flip it over and I divide by, well, I multiply by the reciprocal. So it's going to be 15n, n plus 1, 11 to the 2n plus 1. So again, cancellation. All these guys take out all but one of the 15s. These parts are just going to go to one, so we're not going to play a role. This is interesting right here. Check this out. You actually have two more 11s on the bottom than on the top. You have two, however many you have here, you have two more down here. So what's going to happen is that all these guys are going to take out all but 11 squared. So you're going to get lim as that n goes to infinity. Well, you get a couple constants here. You get 5 over 11 squared. And that's going to be less than 1. So the series will converge. Um, does that make sense? Does that help?
Yeah, I mean that like the ratio test, yeah, that squared away. Um, do we need to know how to do like all of the convergence tests, like the like integral, alternating series, root tests, like comparison test,
Um,
geometric series?
the most of the questions just ask you to they ask you to come up with whatever L is. Usually they just tell you which one to use.
Okay.
Um, yeah, I think you're going to have to. But to be honest, I'm just looking at a few here. Um, Usually, I mean, I would say with some practice, usually you kind of get it on the first or second try. Um, you almost never use the root test. The root test is only if you have everything raised to a certain power. The ratio test, the comparison tests are usually the most common. I mean, really, the whole point of all this is just to come up with ways to show whether certain series converge or diverge. It's the convergence series that we like because they actually can be useful. That's how we can actually, when you guys get to Taylor polynomials, you can see how certain transcendental functions like the e function, the sine, cosine, etc., can be expressed as polynomials, which is kind of cool. I mean, I can jump around all over the place. Is there any questions from that you like looked at from the conversion series convergence tests?
Not that was the thing, is it like didn't the lecture kind of went over the ratio test and then I think that was pretty much it. And then all the
Okay.
questions were pretty much just over the ratio test, but then in a couple of them they would be like, okay, well the ratio is 1. Now what? What do you do? And you're like, oh, I don't know what to do. Because
Well, I'll tell you
all
what,
of
I
the
got one here I can
ratio
bring up.
tests, like 4,
Yeah, I think I was looking
4
at the
and
same one. It's
8.4. I don't know if it's the same for everybody, but
this one right here.
I think so. Yep, that's pretty much exactly what I have.
So we'll go ahead and do it. Let's stop the share. If I do the ratio test, now when I do the absolute values, the blinker here is going to not be an issue for the moment. We'll talk about that here in a second. You have n plus 1, and then all the other guys get n plus 1s. And we're going to divide by this expression, so we're going to flip it over. Oops. And again, the blinker, the little negative end of the end, negative one at the end, we'll get that in a moment. All right. You don't have to get too fancy here. In fact, I can tell you right now, if you just look at this whole monster, this is going to be an n cubed polynomial on the top after you FOIL it all out. This will be an n cubed polynomial on the bottom. And they're going to have leading coefficients of 1. So this is actually going to go to 1 over 1, which is 1. So the ratio test is inconclusive. And this always happens when you have a series where the general nth term is some combination of just polynomial terms. Okay. Now in this case, the ratio test doesn't give us any information. So we're going to have to look at another test. And in a case like this, um, I actually do what's called the P-series test. And I'm going to give you kind of a heuristic approach to it. Basically, a series of this form where it's 1 over n to the p is convergent if p is greater than 1, and it's divergent if p is between 0 and 1. If 0, you just get ones. So in this case, what I would do is I would look at what I have here and really much just kind of ignore all the subsequent these basically the leading terms are going to dominate. And so when I teach this in class, I say as n goes to infinity, this expression is approximately equal to just n over n squared because the 5n plus 2's become negligible. That's the same as 1 over n. I'll use squiggly equals. Well, that diverges. This is the harmonic series. It's divergent. Okay. So the series right here, so I'm going to write it out. If I don't have the blinker, this series would be divergent. Okay. Now, when I have the blinker, and that's what I call the negative 1 to the n power. Suddenly it's going to become convergent because the absolute value of these terms decrease to 0. Now, it'll converge slowly. This is, in fact, this is actually conditionally convergent. What that means is that without the blinker, it's an alternating series because it has the blinker, plus minus, etc. Without the blinker, it'll diverge. With the blinker, it converges. So when you're on that boundary, it's called a conditional convergence series. Okay. Now, what does it converge to? I have no idea. We could put it on a spreadsheet and get an approximation, but it'll converge. It'll converge slowly. That's part of the problem with conditional convergence. They don't converge quickly at all. And that's pretty much, I don't know. Let's go back to the question because let's see what kind of phrasing it wants. So I'm going to share the screen again. So we have a series here, blah, 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 and this probably you must attempt to use the ratio test. Well, yeah, you know, who's going to watch it, right? Here we get, what, God, didn't mean to do that. I hate when it does that. Give me a second. Infinity, grr. So where this L is, I would type in a 1 and I get a divergent. So I guess the ratio test series says that the series, you know, that's kind of weird. Actually, the ratio test says it diverges. It doesn't tell you anything about conditional convergence. I'm gonna see what the actual problem says. I'm gonna see what the solution says. So, oh, I see. The ratio test is inconclusive, but the series converges. Now, in this case, this is different values. So in this case, okay, so I would choose it's inconclusive, but it converges conditionally by other tests or tests. I'm not so sure I like that question. Could be phrased better. Um, Have I confused you guys enough?
That P series test thing makes some sense. Is there some other lecture videos that or content that goes over kind of the different series tests or different types of series? Because they've mentioned them a lot in like different affinity problems and like the example problems being like, oh, well, this is the harmonic one or this is the, whatever one. But like in the lecture videos, it doesn't really go into that. And so I kind of caught myself like having to like, I don't know, look around and try and figure out what a harmonic series is or what a, whatever have you is.
Give me a second here. I'm gonna go to a video page here. I'll share my screen. This is a page that we have that has all the videos that are in Canvas. You can see the URL right here. Um, I don't know if it has extra videos. These are all the videos that they're on a server, and this is kind of our backdoor way to the videos in case Canvas gets um, slows down or crashes. So you have all of these. Maybe these will help.
Oh
You'll
yeah. The only video that we had was just like the ratio test. So
All right, I'll tell you what.
yeah, that might be handy.
Give me a second here. I'm gonna put this in the chat. Now, I'll tell you what I'll do. Might as well do it right now. If you guys don't mind, I'm gonna go ahead and let's see how do we get there. I'm gonna put this in an announcement. I'm gonna do it right now because if I don't do it right now, I'm gonna forget. I'm gonna put this in an announcement in Canvas. All right. All right, so I just sent it. Honestly, I guess on the exam, I guess it just depends on how the questions are phrased, but truthfully, you can use any test as long as you get it right. It would appear that in certain cases, they want you to try a certain test and make a conclusion. Obviously, some tests won't work. I guess if you're learning that too, you'll hit one that doesn't quite work, and you have to make a conclusion based off of that. How are you guys doing with Maclaurin and Taylor?
Not too bad, although I was actually going to ask about one of these. It was one of the example problems that they went over, and I didn't really see anything super similar to it in Infinity, so I don't know if that comes into play, but it was basically finding the first three non-zero terms of a Maclaurin series, and it was e to the 2x times sine of x. Um, and so I think in the example, he took the Maclaurin series of e to the 2x and e to the sine x separately,
Yep.
and then kind of like, yeah, did a whole thing. I don't know, can you just go into that? Because I didn't really
Yeah.
like, that was like the only example like that. And I was like, I don't know if this is something that, because
Let
in
me
some of
write
the
out
other
a few.
ones, oh, sorry.
No, go ahead.
I was gonna say in some of the other ones, it seemed like would be something like this where you have two things kind of multiplied, but instead of taking both separately, it was you do one and then multiply it by, if it was like x cubed or something, you could just multiply it by x cubed in
Right.
other series instead of. So I didn't really know what the rule was for when you do it this way and
I'll,
when you do it the other way.
well, I'll show you. Let me write out a few. I'm writing out the first few terms of this Maclaurin series for e to the x and sine x. Um, the e to the x has a nice pattern to it. It's x to the n over n factorial. The sine function is an alternating series. It's x to the odd factor, x to the odd power divided by that same odd factorial. Cosine would be the even, so it'd start with a 1 and then go minus x squared over 2 factorial. So in a case like this, where you're going to multiply, okay, now we need to get e to the 2x. Well, that's easy. We just put a 2x for the x's. Now, 1 factorial is just 1. I'm going to go ahead and write these as just the normal numbers. 2x squared would be 4x squared. 2x cubed would be 8x cubed. I think that's enough. Let me clean that up even. It's going to be 1 plus 2x plus 2x squared plus 4 thirds x cubed, blah, blah, blah. The sign is good to go. So we'll take these two guys right here. How many terms do they want?
Three.
Three. All right, well, that's easy. So what we do is you just kind of cherry pick what you're going to multiply. You're basically going to multiply this expansion times this expansion. Now, if you multiply the two first ones, you get the lowest possible power of x. And it'll just be x. So x times 1 is x. And then I look and I say, well, what happens if I multiply 2x and x? That gives me 2x squared. And then and there's no other way to make 2x squared. There's no other way to make an x squared out of this. Now I can make an x cubed. I can go these two guys together, make an x cubed. So um, that's a 6. So it would be 1. So it'd be 1/6 x cubed. And then just for the heck of it, I could make an x to the fourth by multiplying this term and this term. So I'd have 2 over 6, so minus 1/3 x to the fourth. And if I wanted to make an x to the fifth, I could do it by, actually, let's see. Oh, you know what? There's another way to make x to the fourth. I could take this term here and this term here, so it'd be plus 4 thirds x to the fourth. So that actually makes just an x to the four. So basically, you're just kind of cherry picking among the terms to try to get certain powers. It looks like they just want the first three. That's what you're going to get. Okay. Um, and one way to check it, it's kind of cool, is you go to Desmos and you graph the function y equals e to the 2x sine x. And then you separately you graph this function and you see how much they conform. In fact, heck, why not? Let's do it. It's fun. Let me go to Desmos and I'll share my screen.
So when
All
you're
right.
getting answers like that are a Maclaurin series, it should always be something x to a power, right? Maybe even 0 or 1.
Yeah, Maclaurins are basically um, what's the one I'm looking for? They're basically polynomial equivalents of transcendental functions. It's the way to kind of bridge the gap. So here I've graphed y equals e to the 2x sine x, and you can see it's crazy. Now I'm going to graph I'm going to graph y equals, and our function came out to x plus 2x squared, take away 1/6 x cubed. And if I zoom in, especially around 0, yeah, that's pretty good. You see how it's conforming there? That blue graph is conforming to the red graph. That indicates that this is a good conformation. That's the idea, is that this function in the polynomial form approximates this function around x equals 0. If I add on more terms, I'll get more and more conformation. Okay. So that's an indicator that you got it right. As far as say a case when they want, let's suppose they want, let's say you have x squared cos x. In a case like that, write out the cos. Let's go ahead and do that. It's going to be 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the fourth, take away 1 over 6 factorial x to the 6, and so on and so forth. And then this is x squared is already a polynomial. So its Maclaurin polynomial is just going to be x squared. All right, so we just multiply everything by x squared, and suddenly x squared cos x is just going to be x squared, take away 1 over, this is just 2, 1 over 2, x to the fourth. This is 1 over that, 24, x to the sixth, and this is what, factorial, my bad, 720. So it's minus 1 over 720, and that'd be x to the 8, etc. So in that case, you can just distribute it through. Um, and again, you could check it. You could graph this and then graph this separately. Maybe just take the first three terms. And if you see that they're conforming pretty closely, that means you got a good answer.
Really.
So you're asking about the radius of convergence. Well, you want to know over what interval are these polynomial approximations or these power series equivalent to the original transcendental function. In these cases, the radius of convergence is actually the infinity. If you go out far enough, it'll completely conform to e to the x theoretically. And same for sine and cosine. Um, so it's really a question of, it's one thing to have an approximation, but how good is that approximation? Sometimes the approximations are really good, but they're only for a very limited set of values. It might only be from like -1 to 1. Sometimes in these cases, like e to the 2x and sine x in their product, the conformation is, if you go out far enough, it's actually going to be over the whole real line. So that's an important thing to know. When you do functions of the form, here I'll just draw one. This is a common one. You can do this by long division. It's going to be 1 plus x squared plus x cubed, x fourth, etc. But this is only true between -1 and 1. So the radius of convergence is 1 because the center is 0. It's a good convergent series, but it's only good for a limited set of values. So if you let's say you have 2 over 1 minus 5x. Well, the 2 just becomes a multiplier, so it's 2, and then we just do the whole thing on the inside. It'll be 1 plus 5x plus quantity 5x squared plus quantity 5x cubed, etc. And that's a good conformation, except it's only good between when 5x is between -1 and 1, or equivalently when x is between -1/5 and 1/5. So it's got a very narrow interval of convergence. It's good. It's in this interval, it's great. Unfortunately, that's pretty darn narrow, right? If you were to graph this, let's say you work this out. So if you work this out longhand, you get 2 plus 10x. This would be 25, so plus 50x squared. This would be 125, so 250x cubed. You would actually see that this thing here and this thing here, if you graph them, are almost they're very nearly the same identical graph. The problem is that it would only be true in a very, very narrow interval. The good news is that with the e function, etc., it's over for all real line. So it's very powerful.
So if a function has any of those ones where it's infinity, like sine, cosine, e to the x, the whole function would be across the whole real number.
Yes. Usually the rule is that you take the smallest possible interval. So whatever functions are you're using to compose the bigger function, if one of them has a limited interval of convergence, that will kind of govern the whole overall function. I suppose if you really wanted to get clever, you do 1 over 1 minus x times e to the x. Yeah, this will work, but this one has a limited interval of convergence. So this is between -1 and 1. This is between the whole real line, but their product would just be between -1 and 1.
Gotcha.
You'll be using, if you get to differential equations, we tend to use the Maclaurin series a lot because unfortunately some of these E functions, they're not very friendly when we start getting integration. And that's actually seen now. You can't integrate, I'm sorry, that one's integral. You can't integrate e to the x squared dx. You just simply can't do it. So the best way to do it is to come up with the Maclaurin equivalent and then integrate that, which term by term. So if you can't integrate it directly, you can integrate its equivalent or its approximation. At least you get a really close approximation. Better than nothing. Forgot to undo the pause. So let me remind, my bad. This is number 15 on 8-7. All right. This looks messy, but it's actually not that bad. What I want to do is I'll clean it up. Just actually, you know what? I'm going to pull the 3/2 x squared out in front. You'll see why. I'm going to write this as x to the 6th over 4. That's the derivative. Now what I'm going to do is I'm going to write out a few terms. This is, I'll just use that form. It's going to be 1. Now this is going to be alternating, so it's going to be 1 minus x sixth over 4 plus x to the 6 over 4 squared. Take away x to the 6 over 4 cubed plus x to the 6 over 4 to the 4, etc. I'm going to go ahead and distribute. I'm kind of thinking as I do this because this is kind of a weird problem. It's going to be 3/8 x to the 8. This is going to be x to the 12. It's going to be x to the 14. So it's going to be 3 over 32 x to the 12th. This is going to be, I'll do one more. That'll be x to the 18. So x to the 20, it'll be negative 64, 128. So 3 over 128, x to the 20, blah, blah, blah. What my thinking was is I was going to turn this back into the arctan by integrating. I'm not so sure I want to do that actually. Um, when I take the ninth derivative, these are going to be gone. By the time I get to here, I'm going to have 12. So I'm just going to kind of heuristically do this. I hope you guys hang on, fasten your seatbelts. By the time we're at the ninth derivative, so that's 8 more derivatives. The second derivative, this will be a 7th power. This will be a 1st power. This will be an 11th power. By the time we're at the third derivative, that'll be a zero, that'll be a constant, sixth power. Fourth derivative, that'll be a fifth power, five, six, seven. So by the time we're at the ninth derivative, this will be gone. So the first term will just be gone. This should be gone because we're going to be down to constant. So this is what we're going to have here. We're going to have, oh geez, 3 over 32. I'm going to have to just kind of work this out. The second derivative would give me a 12, third derivative would give me 11, a fourth derivative would give me a 10, a fifth derivative will give me a 9, a sixth derivative an 8, a seventh derivative a 7, an eighth derivative a 6, and a ninth derivative a 5. And then would have x, this would be to the fourth. Oh my God. You know what? This is absurd. I'm not going to have this on the test. I'm decided I don't like this question. Um,
Sounds good to me.
yeah, I think
I didn't
I'm looking at the
go
key.
through it.
It's oh, they wanted it x equals 0. All right, I missed that part. I was trying to get the general derivative. Um, it's going to be 0. Oh, okay, by the time I get to the ninth derivative, um, okay, actually, this is going to be 0. I think this will survive as a constant. Yeah, you know what? This is absurd. This is not really why we do math. I'm sorry. I'm a little annoyed at that question. It's a nice kind of like what I'd call a recreational problem. It's just fun to sometimes try to figure it out. So yuck. But I'm not going to test you on it. No. You'll never, ever, ever encounter a ninth derivative anywhere. Unless you do like, I don't know. Actually, I have no idea. I can't imagine you would. Yeah, I don't know. The idea is to just detect a pattern. By the time you get down, see, this will be gone. This will still have a power. So by the time we plug in 0, it's just going to be 0. All subsequent terms will be 0. This guy, I suspect, is going to stay as a constant. So it's going to be. We just have to figure out. It'll be 3/8, and then it'll be the second will have 8, 7, 6, 5, 4. So I'm going to do that. It'll be the negative 3/8. It'll have that'll be the second derivative, third derivative, fourth derivative, fifth derivative, sixth derivative. Confusing myself. Seventh derivative, eighth derivative, ninth derivative. Yeah, that's what will happen. It'll be that number. Okay, there you go. You happy? All right. Well, we're getting toward the end here. Any last questions before we sign off? So the reminder, this quiz is it's going to start on Monday and run through Tuesday. I have it set to start at 4 p.m. Mountain Standard. Make sure you take into account whatever time difference where you are. And it's the same protocol as a test. So once you start it, you have to finish it. You get one submission, and then you can correct your mistakes, and then you can submit it a second time. So it's like a test in terms of its structure, but you're not being proctored. So you won't go through an honor lock. You'll just go right to Infinity to take it. But make sure that you allot the time for that. And I'll put this all in an announcement anyway. I was going to do that tomorrow morning and send it out. Maybe I'll do it late tonight. And then I'll have updated grades. I know we're getting into the Thanksgiving holiday, but I'm going to try to knock out the grades by Wednesday. I don't want this thing hanging over my head. And that way you'll know where you stand going into the long weekend. All right. Well, again, thanks for joining me. I hope this was enlightening. Um, these things are kind of cool. They can be a little annoying, I'll admit. So be checking your Canvas announcements, your email for any announcements, and good luck on the Chapter 8 quiz. So I'm gonna go ahead and sign off. So 5, 4, 3, 2, 1.